Hello guys, welcome to another Dosbenching video, where we'll be taking a look at this IBUS Tigershark single board computer. It is primarily designed for embedded computing applications, with a compact and versatile board suitable for various tasks such as industrial automation, robotics, IoT devices, digital signage, and other embedded systems. With its powerful processing capabilities, low power consumption, and various connectivity options, it can be customized and deployed in a wide range of applications requiring reliable computing performance in constrained spaces. IBUS, short for Intelligent Bus, is a technology developed by Intel. It's an interconnect technology used for connecting the processor, chipset, and other components in a computer system. IBUS was introduced by Intel in the mid-1990s as a successor to the earlier VL bus and PCI bus architectures. The IBUS technology aimed to provide higher bandwidth and improved performance compared to its predecessors, and was initially used in Intel's Pentium and Pentium Pro processors and their associated chipsets. IBUS was later succeeded by other interconnect technologies such as AGP, or Accelerated Graphics Port, and PCI Express for general-purpose expansion cards. While IBUS itself may not be widely recognized as some other Intel technologies, its development contributed to the evolution of computer architecture and the improvements of the system performance during the late 20th century. This particular SBC's configuration consists of an Intel Pentium 233MHz MMX CPU installed at the heart of the system. Located next to the CPU socket in this brown socket is the 512K Level 2 cache module. The Intel Pentium 233MMX only has a Level 1 cache integrated into the processor, which is a 16KB 4-way set associative code cache. That's a bit of a mouthful. In modern processors, all caches are now integrated into the processor. Situated next to the cache is 32MB of EDO memory over two 72-pin SIMs. To test this system, we're going to need just a couple of items: a PIC MG backplane, the single board computer, and a graphics card, as there is no integrated display on this SBC, and finally some kind of boot device, which for testing is always my IDE to CF adapter and a micro drive. For display, I have selected an ATI MAX64 1MB PCI VGA graphics card. The ATI MAX64 was released in 1995 with the MAX64 GPU using the Mac architecture, a 600nm process, and it has 1 million transistors. The card has a 64-bit GUI accelerator with basic DOS support, limited Visa VBE support, and a 64-bit memory interface. After several unsuccessful boot attempts, I managed to get a post screen in the end using an ISA Trident TVGA 8900C VGA graphics card with 512K of video memory. It isn't ideal for getting a good overall score of the system, but at least we can test everything is running properly. We'll start gently with option number 2, 3Dbench 1.0C for faster PCs. We get a score of 35.1 FPS, and I have no idea if that is good for this setup, but all seems to be working as it should be. Up next is PC Player in 320x200 resolution. .1 FPS is the result, so let's see what score we get in 640x480. PC Player in 640x480 resolution gives us the unpleasant score of 5.5 FPS. I say unpleasant, but back when computers had limited horsepower, you'd have put up with that, just to play the game. Let's now see how we get on with Doom. This would have been one of those games I was referring to, putting up with god-awful frame rates, just so that you could play the game. Timed 2,134 game ticks in 6,382 real ticks. That works out to 11.7 frames per second. That is higher than I thought it was going to be, if I'm honest with you. On to the quick time demo now, and let's see how we get on. Quake scores quite an impressive 20.7 frames per second. I'm actually surprised more that Quake achieved a higher FPS score than Doom. Very surprising. The final benchmark now, which is SpeedSys. SpeedSys is a benchmarking tool commonly used to assess the performance of DOS-based computers. However, for modern systems running contemporary operating systems like Windows, SpeedSys might not be as useful since it's tailored for DOS environments. For more relevant and comprehensive performance metrics for current hardware and software configurations, benchmarking tools such as PCMark or 3DMark would be a more suitable choice. SpeedSys measures various aspects of the system performance, including CPU speed, memory speed, disk performance, and video speed. We're not going to be looking at the disk performance though, because our disk is a microdrive, and that seems rather pointless. For assessing the performance of older DOS-based systems though, SpeedSys can be quite effective. It provides a standardized way to compare different hardware configurations, or can be used to diagnose performance issues on the tested system. The processor is showing as an Intel Pentium MMX 233MHz with the code name P55C, a memory size of 32MB with a memory bandwidth of 221.91MB per second. Visa OEM copyright 1988 to 1991 Trident MIC, which is the graphics card, with a Visa memory size of 512K. And in brackets, it has 1080KB a second, which I would assume is the transfer speed of that memory. Hard drive is 341MB, and the chipset is an Intel 82430HX Triton 2 chipset. BIOS is IBUS A Maxwell Technologies, released on the 27th of May 1998. OS version MS-DOS version 6.22. Now to the results. The processor benchmark score is 177.97, and that is right around where it should be, P55C 233. The memory timing results are as follows. The 16KB data cache level 1 transfers at 422.91MB per second. The 512K level 2 cache, which if you remember is located in the brown socket next to the CPU, that cache transfers at 182.94MB per second, far less than half the speed of the level 1 cache that is on chip. The memory throughput is 123.10 megabytes per second, and that concludes the results from SpeedSys. All is working well on the IBUS Tigershark, and that brings us to the end of this video. I hope that you've enjoyed watching. If you have any comments, please leave them below, and I will catch up with you guys soon. Take care everyone.